This part of the coding is used to plot the signal plot. The method is as depicted in phase 1. This part of the coding is used to plot the frequency spectrum of ECG1. The method used is as discussed in Forum 2. As you can see, the signal in ECG1 is distorted. Noise can also be seen at the 50 Hz range. The objective of phase 3 is used to filter the noise and smoothen the signal plot.
For the filtering part, we are using the Hamming window to design a low-pass filter to ECG1. The low cut-off frequency we want is at 40 Hz. To obtain the omega C, we use the formula of omega C equals to 2 multiplied by low cut-off frequency divided by sampling frequency. To use the FIR1 function in the MATLAB coding, we need to decide our number of order in order to smoothly filter the noise from ECG1. We apply the for loop function to help us in trying different order starting from I equals to 1 until I equals to 10. And then, the frequency spectrums of each filtered ECG1 are plotted by using the same method as shown before. After observing the spectrum of filtered ECG1, we decide the value of I and order of the filter. With the decided filter order, we plot the signal plot and frequency spectrum of the filtered ECG1 signal, and the result is compared with the ECG1 without filter.
This diagram shows the comparison between the original ECG1 signal and filtered ECG1 signal. The signal plot of ECG1 shows that there is a lot of noise interrupting the original signal. Using frequency spectrum of ECG1, we can detect the frequency range where noise is found, which was at around 50 Hz. Diagrams below shows plot of frequency spectrum for different order of filter starting from I equals to 1 until I equals to 10. After observing the spectrum of filtered ECG1, we decide the value of order of the filter. We can see now there is no more spikes after the frequency range of 40 Hz as compared to the original signal. This step followed by plotting the signal plot and frequency spectrum of filter. Graph of magnitude plot of ECG1 signal becomes smoother as most of the noise successfully filtered out.